This video is based on Z hypothesis testing. We have this example here. So you have a study that assesses and compares the effectiveness of three pesticides A, B, C on the tomato plants. Data was collected to determine the pesticide's impact on plant health. The goal is to determine if the new pesticide significantly improved plant health compared to the known baseline or known mean or known control. So plants without any of the pesticides, right? So the effectiveness is measured as a percentage of healthy plants, and higher percentage indicate better effectiveness. So it's as if you take the plants, you give them the pesticides, and then you leave them for a while, you come back, and then you measure how many of those plants are healthy compared to the how many are not healthy. You get it as a percentage. So the higher the percentage means the pesticide is more effective. And 80% means baseline, right? That's without any pesticide, 80% of the plants are going to be healthy. Right. The baseline or the mean representing healthy plants is 80%. The standard deviation is 2.2%. Each of the three pesticides was tested, and the results are attached in the Excel file. Each column represents the effectiveness as a percentage of each drug or each pesticide, it should say. So here you have the data. You have sample ID, so you can just have a look at the data. So before you analyze any data, just have a look at it. What does it look like? Here you have 50 samples or 50 sample IDs, and you have three sample sets or three variables. So the variables, you have the pesticide A, pesticide B, pesticide C. So you have three different pesticides, and for each pesticide, you did 50 experiments, right? So you have 50 replicates to really get an idea of the effectiveness. So to make sure that your results are not biased by experimental error, you did it 50 times. So you have the results there, and the idea is you're gonna import these results to Minitab. So one way to do it is just to select everything. So I'll just select the part that I need. I need the actual pesticide data. I don't need to know the sample ID, for example. So I might just not import that column here. So I'll copy these in Excel by just selecting them and then hitting copy, and then I will paste them into Minitab. So if I paste them into Minitab, this is what it will look like. So it looks like something like this, where you don't have, so I will just delete this material that I already did. But when you paste it, you won't have any of this material. You just have the data that you have here, pesticide A, pesticide B, pesticide C. Right. So you can move this up and down just to see the data better. So now the next thing is you want to get some summary statistics. So the first part is import or copy the data in Minitab, which we just did, and calculate the mean and standard deviation of each pesticide using the calculator, and also use the summary statistics function in Minitab. So we're going to do that. Let's start with the summary statistics part because it's easier, and we did that in the first lab. So to get summary statistics, what you do is you go on Start, Basic Statistics, Display Descriptive Statistics, and then you just select the three pesticides here. So originally there will be nothing here, and then you'd select pesticide A, pesticide B, pesticide C by just double-clicking the left side of the mouse, and then you hit OK. When you do that, again, you can move this up and down to visualize things in here. You will see the summary statistics here. So normally you pause and read these to just get an idea of your data. So for example, you can get the idea of the means. Mean of A is 80, mean of B is 80.6, mean of C is 80.2, and so on, and you have the standard deviations as well. So by the looks of it, it seems that B has a higher mean than everyone. So it has 80.6 as the mean. So it seems it's more effective. It also has the standard deviation here, which is low than the other ones. So yeah, just good to know to just visualize the data. You see the minimum values and the maximum values as well of each column. You see the medians, the quarter one, quarter three, and so on. And it also tells you how many data points it has. So each one of them has 50 there. So yeah, the summary statistics. And again, you can also calculate them manually using the calculator. So Minitab can also be used as a calculator. So for example, I can name these columns like mean A for this one, mean B, and then call this one mean C. And then maybe I can also have another column for standard deviation of A, right? So I want to calculate the mean A, mean B, mean C, and then put those values here, right? So I just created a new variables here. So the mean of A, to calculate it, I go on calc, and then I go on calculator. And then here, I want to store that result in the column that I called mean A. And the result that I want to store, so here under functions, I will select statistics. So Minitab can do a lot of things, arithmetic, text functions, trigonometry, etc. So what I want is statistical functions. And then I go in this box, and then I select mean. So I want to calculate the mean, and then it gives me this. So inside there where it says number, that's where I put the input, the thing that I want to calculate the mean of. So for now, I want to calculate the mean of A. So I double click A, and then it looks like that. I hit OK, and my result is stored here. So I can do the same for B. Again, the same thing, calculator. And then I want to store this result in mean B this time, the column I called mean B. Just make sure the spelling is uppercase. If you use lowercase, Minitab won't be able to find that column because it doesn't exist. So just make sure you put the correct spelling and correct case. And then here, instead of saying A, pesticide A, I delete everything in the bracket, and then I put B this time. And then I hit OK, and my result is stored here. And again, I can repeat this process again for C. This time I want to store it in C, and then I can have it here. So change that to C, and then hit OK, and then the result is here. And again, I can get the standard deviation for A, for example, again, by calculator, and then I can want to store that in standard deviation A. So that's the name of that column, standard deviation A. And then I want to calculate standard deviation. So standard deviation is here. So I get standard SDDev, shorthand for standard deviation. And I want to get standard deviation of A. I want to store it in SDA, which is this column here. I hit OK, and there it is. So I have my values there, and they are matching with these values. So the mean of A is 80.16. I'm getting 80.16. Mean of C is 80.2. I'm getting 80.2 here. Standard deviation of A is 1.9. I'm getting 1.9 here. So obviously this is a quicker way, but also you can do things manually as well if you need to do that. So yeah, you can also get standard deviation of B, etc. manually, and minimum, maximum values as well. You can do that. Okay, so the next part is an interval plot displays the means of different pesticides on a single graph for comparison and visualization purposes. Plot an interval plot using the data for the three pesticides. In your interval plot, insert a horizontal line at the population mean, 80%, so the baseline, and remove all other horizontal lines in the graph. Upload your graph on Moodle, and then the next question is which pesticide has more variability and which one is the highest mean? Enter your comments. Right. So I'll go back to this, and they asked me to create an interval plot. So to do an interval plot, what you do is you go on graph, because it's a graph, and then you go on interval plot, and you select this one here. So because I have three samples, I have multiple Ys. So Ys is another name of saying outputs. So I have three Ys, or three variables or outputs. So I use this one. You have Y1, Y2, Y3, pesticide 1, pesticide 2, pesticide 3, etc. So I want them to be displayed on the same graph. Whereas if I pick this one, you do one at a time. And this one is when they are grouped. I don't have any groupings. Okay. So I select this one and I hit OK. And then I want the three pesticides to be displayed in interval plots. And I hit OK. So when I do that, I get the interval plot, which is there. That's the interval plot. It has the bars and everything. So they asked me to add a horizontal line at the population mean. So add the baseline line so that it can be easy to visualize if these samples are above or below the mean. Remember, the dot means the mean. Yeah, so the dot is the mean, and this is the error bar, right? So to edit the graph, I right click and I go on edit graph. And then I can start by just deleting material that I don't need. For example, the title, by just selecting it, hitting delete on your keyboard, selecting it by just clicking it one time with the left mouse, delete, selecting it, delete, right? Another thing is deleting horizontal lines. So select one of the lines, hit delete, select one of the vertical lines, hit delete as well, like that, so that it doesn't have lines. And then I can also see this title here saying data. That means nothing. Data just means information. But I know that this is percentage effectiveness, so I can edit this to that to make it make more sense. So I can say effect percentage, And I can maybe change the font to Times New Roman, for example. And maybe I can make it bigger, maybe 16, and apply the same to all axes. So all axes will be the same font size. And then I hit OK. My graph looks a little bit better. I can also notice that the numbers are small here. So I can make them bigger, double click one of the numbers, and then it will show you all these attributes that you can change. I want to change the font, so I can change the size to 16, and then apply it the same to the X, and then also make sure the font name is the same. So I'm going to use Times New Roman here and hit OK. So maybe 16 is that's too big for the title, so maybe make it a little bit smaller, maybe 12 is okay. Okay, that's better. So we need to add a line at 80 to just show the best line. So you add item here, and then you go on reference lines, and then you go. So Y is the vertical, so you want to add it to the vertical. You don't want to add any line in the Y in the X direction. So you want to edit like a horizontal line. So reference line at Y value equals 80. I hit OK. So that line, it's a good visual representation of that's the baseline, the control. So I can see that all my samples, they did better than the control in terms of mean values. But I can see that two of my samples are overlapping with the baseline. Some of the material is below. Okay. So that means these two samples are insignificant. Okay. They don't have a significant effect, although they actually are above the line. It means that when I do the hypothesis testing, these are not going to be significant. But more on that later. This graph is just to quickly see that as a visual representation. And I can clearly see that this one, so the length of this error bar shows how much variability is in the sample. So clearly this one is the highest variability, okay? It can vary from anywhere between 81, somewhere around 81 to down to 70. This one can vary between about 79.75. So this one is the highest variability, highest mean. This one is the highest mean, and the lowest mean, I think, is this one is the lowest mean, because this one looks like it's above that. So that will be the answers and then that's the interval plot. The next thing is to conduct a one sample Z test, Z hypothesis testing, using 95% confidence. So that's important. That could be any percentage. So you need to make sure you can change it. But by default, Minitab starts at 95% because it's the most popular confidence 0.5. So do a hypothesis test on each of the three pesticides and then find, and in your report, clearly state the new hypothesis, the alternative hypothesis, and ensure that the option perform hypothesis tests. So this is how you perform a hypothesis. So you'd go in Minitab and so here's my graph. Just close this off. You go in Minitab and then you go on statistics, basic statistics, and so you select one sample Z, and then in here, in the box here, you would select the material you want to perform hypothesis test on. So I click in that box and then this populates, and then I select A, B, and C, and then I enter the standard deviation. So the standard deviation, they told me it was 2.2. I hit perform hypothesis test here. They told me it's 80. So I put, and here under options, you can change it to 99, for example, 99%. If they say 99, I can change it to 60. But they say 95 in the question, so I say save it to 95, I hit it. And then here under graphs, you can select that I want to see the histogram, the individual value plot, and the box plot. So I don't need to see this in the Moodle answers, but you can select them just to visualize the data more and hit OK. And then you hit OK again. And so on pen and paper, this will take you 10, 15 minutes to conduct, to do the calculations. On Minitab, it's a few clicks. So here is the hypothesis test, and the real results, the main results that you're looking at are these. Right? So you're looking at this, it gives you the Z value. So for pesticide A, it is Z91. So starting with the p-values, if you remember in the class, I said a p-value greater than 0. Okay, so if it's above 0.05, it's significant. As you can tell here, this is about 0.05. because it's 0.5, definitely above 0.05. So that sample is not significant according to the p-value. This one is 0.04. That's significant. It's below 0.05. This one is 0.3, again, insignificant, which is matching the interval. The interval plot was telling me B was the significant one because it wasn't overlapping with the baseline. So that's the p-values, but also the z-values. If you remember, the critical z-value when you do a z-test at 95% confidence is 1.96, right? So, for example, pesticide A, it's 0.54. So 0.54 is clearly between minus 1.96. So that means I would accept the new hypothesis for that. And then for this one, for pesticide B, it's 2.04. 2.0 is clearly above the 6. So for that reason, and then C, it's 0.9. Again, 0.9 is in between 1.96 and minus 1.96. So I would accept the new hypothesis and say that it's not significant. Again, Minitab just gives you this, but in the report, you would have to do it in the format that we talked about in class, where I will start with. And then, so the new hypothesis will be the pesticides, the OF, and then I would do them individually and then say that these are the p-values. And from the p-values, this is my analysis and p and z values. And judging from those, and then for C, I accept the new hypothesis. And then my interpretation is pesticide A and C are insignificant in terms of they didn't make any difference to the plants according to statistics. Okay, so part D, what do the Z and the P values you got from part C? So I just mentioned that. So here, obviously, because B was the one with the highest Z value, I would recommend that because it is the highest Z value. Although it might not, we're not looking at the mean or anything like that. So some people report the mean. The mean doesn't matter here. What matters is the Z value, right? So it has the highest Z value. That's why